Azure Storage is a cloud storage solution provided by Microsoft Azure. It offers scalable, durable, and highly available storage for various data types, including blobs, files, queues, and tables. Azure Storage is essential for developers building cloud-based applications as it provides a reliable and secure way to store and manage data. In this presentation, we will delve into performing operations on containers and items using the Azure SDK, a crucial skill for any Azure developer. In Azure Storage, a container is a logical grouping of blobs, similar to a directory in a file system. Items or blobs are the actual data objects stored within these containers. Containers help organize and manage blobs, making it easier to apply security policies, access controls, and other configurations. Understanding the relationship between containers and items is fundamental to effectively using Azure Storage. The Azure SDK, Software Development Kit, provides libraries and tools for developers to interact with Azure services programmatically. It supports multiple programming languages, including .NET, Java, Python, and JavaScript. The SDK simplifies the process of performing operations on Azure resources, such as creating, reading, updating, and deleting containers and items in Azure Storage. Using the SDK, developers can integrate Azure Storage into their applications seamlessly. To start using the Azure SDK, you need to install the appropriate libraries for your programming language. For example, in .NET, you can use the NuGet Package Manager to install the azure.storage.blobs package. Additionally, you need to set up authentication to access your Azure Storage account. This typically involves creating a storage account in the Azure portal and obtaining the connection string or access keys. Creating a container in Azure Storage using the SDK is straightforward. In .NET, you can use the Blob Service Client class to connect to your storage account and the Blob Container Client class to create a new container. For example, you can use the following code snippet: blob service client equals new blob service client connection string. Blob container client equals blob service client dot get blob container client my container. Await container client dot create async. This code connects to the storage account and creates a new container named my-container. Uploading items or blobs to a container involves using the blob client class. First, you need to get a reference to the container where you want to upload the blob. Then you can use the blob client to upload the file. For example, blob client equals container client.getBlobClient my-blob.txt. Await blob client upload async path/to local/file.txt true. This code uploads a local file to the specified container, creating a new blob named myblob.txt. Listing items in a container allows you to retrieve and display all blobs stored within a specific container. Using the blob container client class, you can enumerate the blobs in a container. For example, await for each blob item in container client.getBlobs async, console write line blob item.name. This code iterates through all blobs in the container and prints their names, providing a simple way to list and manage the contents of a container. Downloading items from a container involves using the blob client class to retrieve the blob and save it locally. For example, blob client equals container client get blob client my-blob.xt. Await blob client download to async path to locals file.txt. This code downloads the blob named myblob.txt from the container and saves it to the specified local path. This operation is essential for accessing and using the data stored in Azure Storage. Deleting items from a container is a straightforward process using the blob client class. For example, blob client equals container client.getBlobClient my-blob.txt. Await blob client delete async. This code deletes the blob named myblob.txt from the container. Deleting blobs is crucial for managing storage costs and maintaining an organized storage environment. Managing container properties involves configuring settings such as access levels, metadata, and lifecycle policies. For example, you can set the access level of a container to public or private using the blob container client class. Await container client.set access policy async public access type blob. This code sets the container's access level to allow public read access to blobs. Properly managing container properties ensures security and compliance with organizational policies. Handling errors and exceptions is crucial when working with Azure Storage. The SDK provides various exception types, such as request failed exception, to help you identify and handle errors. For example, try await blob client.upload async path/to local file.x true. Catch request failed exception X, console write line, error x.message. This code attempts to upload a file and catches any exceptions that occur, printing the error message. Proper error handling ensures robust and reliable applications. Advanced operations with the Azure SDK include features such as blob snapshots, versioning, and leasing. For example, you can create a snapshot of a blob to capture its state at a specific point in time. Blob client equals container client.getBlobClient my-blob.xt. Blob snapshot info, snapshot, await blob client, create snapshot async. This code creates a snapshot of the blob, allowing you to restore or compare its state later. Advanced operations provide powerful tools for managing and utilizing Azure Storage effectively. When using Azure Storage, it's essential to follow best practices to ensure optimal performance, security, and cost management. Some best practices include using asynchronous operations to improve performance, implementing proper access controls to secure data, and regularly monitoring and managing storage costs. Additionally, consider using features like lifecycle management policies to automate data retention and deletion, and leverage Azure Storage Analytics to gain insights into usage patterns and optimize storage strategies. In this presentation, we covered the essential aspects of performing operations on containers and items using the Azure SDK. From setting up the SDK and creating containers to uploading, listing, downloading, and deleting items, we explored various operations that are crucial for managing Azure storage. We also discussed advanced operations and best practices to ensure effective and efficient use of Azure storage. As a next step, consider exploring the Azure documentation and SDK samples to deepen your understanding and enhance your skills in developing solutions for Azure storage.